Right, so in this video, we'll be discussing the probability and statistics 2, paper 6, yeah, for February, March 2024, paper 6, 2. Okay, so we start with question number 1. Okay, so they are giving us the length of a sample of 100 insects of a certain type, where it is summarized as follows. So we are having the information like n summation of x and also summation of x squared. So they want us to calculate the unbiased estimates for the population mean. Highlight the keyword unbiased estimates for the population mean and also the variance. So we need to use our sample value to estimate the population mean and also and variance, right? So if you can't remember the formula, it is actually provided in the formula booklet. You go to the probability and statistics part and you scroll down until the part of sampling and testing. So from here, by right, you can see the unbiased estimator. These are the two formula for the estimator. Alright, so the mean, population mean, and also the estimated population variance formula. Right, okay, so we are going to use these two. So if in case you cannot remember the formula, you can still find it out from the this MF19. Alright, so just to recall back, yeah. Okay, so I just want to show you here that the formula. Right, so the formula for the population mean, estimated population mean, it is actually equals to summation of x divided by n. And also the unbiased estimated variance, it will be 1 over n minus 1, summation of x squared, minus summation of x divided by n. Sorry, summation of x whole thing square divided by n. So this is the general formula for this question. Right, so let's start with the mean first. If I want to calculate the unbiased population mean or estimated population mean, basically the formula is summation of x, which is 36.8, and divided by 100. So we are having 0.368. It's very straightforward, yeah? Alright, then after that, we go to the unbiased estimated variance. Unbiased estimated variance. Okay, according to the formula, it will be 1 over n minus 1, which is 99. Summation of x squared is 17.34. Then minus 36.8 square divided by 100, the n. Alright, and just use the calculator to help us. By right, we should get the long value here. And of course, we have to rephrase our answer into 3 significant figures. Alright, so this is how we solve the question number 1, part A. Then let's proceed to part number B. For part number B, they are asking us to state the necessary condition for the estimates to be found in part A to be reliable. Right, so since we are using a sample value, right, to estimate the population mean and also the variance, by right, our sample must be a random sample so that it can represent the whole population. If let's say you are restricted to only one part of the population to form a sample, then it cannot represent the whole one. So the sample must be a random sample so that it is reliable enough, right? So to prove or to represent the whole population. So it must be a random sample. Okay, yeah, so this is how we solve question number 1. Okay, so question number 2, there's a random sample of 250 people living in Barapet was chosen. Then it is found that 78 of these people are using a certain type of phone. Okay, so there's a approximate 95, they want us to calculate an approximate 98% confidence interval. So 98% confidence interval for proportion of people living in the place who own a Bedak phone. Right, so the question is very straightforward. We are looking for 98% confidence interval for proportion. We are having two types of confidence interval, yeah? We're having the confidence interval for mean and also the confidence interval for proportion. What's the general formula for us to get the confidence interval for proportion? Here, basically it is P minus Z square root BQ over N. This is a general formula that we have. And then we're having P plus Z square root BQ over N as well. Right, so we need to plug in all the value P, Z, Q, and so on. So what is the value of the P? So by right, you should know that P is the proportion of people who own the phone. So it will be 78 over 250. Okay, all right, then what's the Q? For the Q means it is 1 minus P. So 1 minus P. And your Q should be 172 over 250. Okay, then N is very obvious. The total number of people in this area is 250. Then maybe now we need to find out the Z. Right, so how to find the Z? Basically, it depends on the confidence in a level that you have. They're asking for a 98% confidence level. That means my confidence level should be having 0.98 in the center. Then by the side, it is actually 0.01 for each side, right? So that when you total up the area for these two parts, basically it is equals to 1. Okay, then the value of Z basically is this one. I want to know what's the Z here for a 98% confidence level. So to get the Z, I need to look for the whole area below the Z, which I need to include the whole area here. It will be 0.98 plus 0.01. So 0.98 plus 0.01, you'll get 0.99. So to get the value for the Z, you have to look for the area of 0.99. Right, so again, I need to go back to the normal distribution table and then looking for the 0.99. So if I have a look here using this shortcut table, right, the probability 0.99 will give us the Z value, which is 2.326. Right, so we go back to our question here. My Z is 2.326. All right, so let us plug in all the value inside the formula. Okay, so what do we have here is we are having 78 over 250. For me, I didn't simplify it. If you want, you can simplify first before you substitute inside. So 2.326. Then the square root PQ over N will be 78 over 250. Then 172 divided by 250. Okay, then divided by N. So divided by 250. All right. Okay, and then next one is the same. Upper limit, just that you change the sign become a plus. Okay, I need to squeeze a little bit. Okay, so please make sure that you substitute all the value correctly, and by use the help of calculator, kindly get an answer. So maybe you need to really practice and see whether you're able to get the answer correctly or not when pressing the calculator. For me, right, if I use everything originally, I'll get, of course, two long numbers here. Then only I cut it short into 3 significant figure. Okay, so by right, my 98% confidence interval for proportion should be these two values, the lower limit and also the upper limit. Right? Yeah, so this is how we found the confidence interval for proportion. Right, then let's continue further to part number B. So there's one guy, Manjit, claims that more than 40% of the people living in Barabat own a Bertec phone. So the keyword here is more than. Alright, then they want us to use the answer in part A to comment on this claim. Alright, so first of all, we want to know whether is the population proportion should be more than 40% or not. Okay, so to check, I will take the proportion 0.40, 40% is 0.40, right? And I want to compare it with my confidence interval. Okay, so from this confidence interval, it said that the population proportion should be between these two values. Proportion should be because this is also just estimation, right? So the population proportion should be between 0.244 and also 0.380. But if you have a look for our value here, he said that should be more than 40%. That means the proportion should be 0.40. So you think that is 0.40 a correct value because we have estimate just now that population proportion should be these two, within these two values. But 0.4 very obvious is already out of the confidence interval value, right? Okay, so you can tell them that, oh, the claim is not true or it's not correct. Okay, so you can make a small conclusion here. The confidence interval okay, does not contain 0.40. Okay, so what does it mean? It means that his claim, this person's claim, is not true. Or we can write in this way, there's insufficient evidence. There is insufficient evidence to show that Manjit's claim is true. Okay, if let's say the value of proportion in the claim is within the interval that we have, then of course it is correct. But if let's say the value is outside the confidence interval value that we get, then basically the claim is not correct. Right? So this is how we make a decision, or maybe to decide whether a claim is correct or not using the confidence interval. Right? So this is how we solve question. Okay, now we are at question number 3. In a certain lottery, right, on average, 1 in every 10,000 tickets is a prize winning ticket. Then the agent sells 6,000 tickets here. Use a suitable approximating distribution. Highlight the keyword approximating distribution. Find the probability that at least 3 of the tickets sold by the agent are prize winning tickets. Alright, so the keyword here is approximating. That means you should change from one distribution to the other distribution for the population, for calculation, okay, of the probability. So you need to investigate a little bit, or maybe analyze a little bit. For A2 syllabus, this is stats 2, right? So for A2 syllabus, we are having 2 types of approximating distribution. The first one is from binomial to Poisson. And the second one is from Poisson to normal. Okay, we need to observe and see originally for this question, what kind of distribution it belongs to. So they are saying that 1 in every 10,000, this is basically the P, the proportion. Alright, and I'm having a total number of 6,000 tickets here. Then at least 3 of the tickets, something happened. In overall, you're having 6,000 tickets. Then at least 3 of them, something happened. This structure of the question belongs to binomial distribution. Alright, so that means for this question, originally, it is binomial distributed. Therefore, this is what we should have, binomial to Poisson. Okay, so what is the n? N is 6,000. What is the p in binomial distribution? It is 1 over 10,000. When I want to change it become Poisson distribution, the lambda, okay, the parameter in Poisson is a lambda. So how can I get the lambda? I will take n multiply with p, because n times p you get mean, right? So the lambda in Poisson distribution here is actually the mean. So take the n, multiply with the p, by right you will get the value 0.6. So this is your lambda for the Poisson distribution, and they want you to find out the probability of at least 3 tickets are prize winning tickets. So x greater equals to 3, at least 3 so included the 3, 4, 5, 6, 7, 8 until infinity for Poisson. So you cannot find out the value until infinity, right? So you have to take 1 minus the probability of x smaller than 3. Using Poisson distribution, yeah? Okay, so for Poisson distribution, I'm having E negative lambda. When x equals to 0, the remaining term here is always a 1. When x equals to 1, the remaining term is always 0.6. Then when x equals to 2, 0.6 square divided by 2 factorial. Lambda square divided by 2 factorial. I shouldn't include the 3 in this part because my calculation for the answer included the 3. So when you want to take 1 minus, it shouldn't include the 3. Right? And after that, just use a calculator and try to get the answer. your answer up to 3, there's 3 significant figures should be 0.0231. Okay, so this is how we change it. Alright, maybe some students will ask, do I need to do any continuity correction from binomial to Poisson or not? Okay, so if let's say you try to observe and have a look here, for binomial, it is a discrete random variable, right? Okay, then for Poisson, it is also a discrete random variable. So from discrete to discrete random variable, basically you don't need to do any adjustment on continuity correction unless you're having discrete to continuous. Then you need to do the continuity correction. Okay, so both are discrete here, therefore you won't see any continuity correction in the solution. Alright, okay, then let's proceed to part number B. They want you to justify the use of your approximating distribution in this context. Like what you know, right? We can't actually simply change distribution from one to the other one. Okay, so like from binomial to Poisson, we cannot just simply change them as what we like. So there are some conditions that must be fulfilled before you can change a binomial distribution become Poisson. So what are the conditions here? Okay, so the first condition here basically is n must be greater than 50. So in our context here, our n is equal to 6,000. So the first criteria is fulfilled. Alright, and the second criteria is actually NP smaller than 5. So if you double check, NP in our question is 0.6, which is smaller than 5, also fulfilled. So these two will be basically the condition that we must have before we can change a binomial become Poisson distribution. Alright, so this is how we answer question number 3. Okay, so we are at question number 4 now. Every year, there's a transport firm use the X liter of gasoline and also Y liter of diesel fuel. Then X and Y are both normally distributed, so you can see very clearly here. Okay, alright. So I think this one should be a linear combination of random variable. Okay, let's have a look for the question. Part 1. Part A. Find the probability that in a randomly chosen year, the firm use more gasoline than the diesel fuel. More gasoline than diesel. That means you're having more X than Y, right? So when you want to write out in a symbol form, it should be X greater than Y. But when you want to calculate the probability, we're not able to calculate the probability like this when you're having both sides with variable. Therefore, I need to move all the variable to one side. That means I'm interested to find out X minus Y greater than 0. Okay, so before I can find out the probability, I need to find out the distribution for X minus Y first. Okay, so how to find out the X minus Y? Okay, so EX minus Y means what? EX minus Y means that EX minus EY, mean X minus mean Y. Okay, so if you use the mean X, basically you're having 10700 minus 13400, and from here you get a negative value, right? Negative 2700. And then if I want to get the variance of X minus Y, it should be variance X plus variance Y. So what do we get here is we will be having 950 square, then plus 1210 square. So please take note on this sign here, it is a plus. Although our original variable, right, is X minus Y, but in variance, it is always having only the positive value. So the negative here will become a plus. Okay, right, then you can try to find out the total for the variance. It will be 2366600. Okay, since I know that X is normally distributed, Y is also normally distributed, therefore X minus Y, it is still normally distributed. With the mean is negative 2700, the variance is this large value here. Okay, then now only I start with the part of probability calculation. So I want to get the probability X greater than 1. X greater than Y. So I move all the variable one side. I will have X minus Y greater than 0. Okay, since I know that X minus Y is a normal distribution, right? It's in a normal distribution. Therefore, I should change it become Z before I can find out the probability. So I take the value 0 minus the mean. So minus the mean for X minus Y is this one, negative value. divided by standard deviation. We got the variance just now. So the standard deviation, I need to take square root. Alright, then simplify the value of z up to 3 decimal places. Okay, so just a reminder, this one must be up to 3 decimal places, yeah? To get the most accurate answer from the normal distribution table. Okay, so for the table, it provides us with all the value z smaller than. So we are looking for the value of z greater than. I have to take 1 minus. So look for 1.755. Okay, so you go for 1.755. 1.75 is this one, right? From top. And then another 5 is this one, which is a 4. So that means we need to add a 4 at the last digit of this number. Okay, so when you add a 4 at the last digit of this number, by right, you should get the answer 9603. So I put it inside here. Okay, I will have the value 1 minus 0.9603. And simplify it, I will get 0.0397. This is to 3 significant figure, all right? Okay, so this is how we get the answer for part A. Let us continue to part B. Now they are talking about the cost per liter for the gasoline and also the diesel fuel, 0.8 and also 0.85 respectively. So they are asking us to find the probability for the total cost of gasoline and also the diesel fuel. Alright, so to get the total cost, first of all, we need to know how to get the formula for the total cost. Okay, so the cost depends on the volume of gasoline and also the diesel that we are using, right? So that means I must have 0.8, which is the cost per liter, multiply with the X, which is the amount that we use for gasoline. Then add with, okay, the cost per liter for diesel, multiply with the amount used. So my total cost should be 0.8 0.8x plus 0.85y. So you have to multiply the x or y with the amount that is used, okay, so that we can get the total cost. All right, then from here, if I want to get the expected value for the total cost, what will it be? It will be 0.8 multiply with the mean of x. So the mean of x that we got just now is 10700. It is provided in first part, yeah? So please have a look. And then plus the mean for y, you take 0.85, then multiply with the mean of y, e bracket y. So the mean of y from part A, we get a value 13400. So when you total up these two values together, you have 19950. Okay, so after you found the mean, we want to find the variance. Okay, so for the variance, yeah, when you want to take out any value, any constant, okay, from the variance, and keep the variable inside, right? When you want to take out any constant, please take note that it must square the variance. For this one, it's a multiple. Multiple question means that you are multiplying the amount x, the x with a number. So when you want to calculate the variance, the constant should be squared. If let's say it is total, then no need to be squared, all right? So please take note on a small detail here. So this one is a multiplication because I take the amount used for the x, multiply with the cost per liter, right? So it is a multiplication. When you take out the constant, there must be a square there. So I'm having 0.8 square. And after that, what is the variance of x? So again, you get it from part A. The detail from part A, the variance of x is 950 square. And what about the y? Also the same thing. I want to take out the constant 0.85, right? I have to square it. And then the variance of y is this one, 1210 square. So you also get the long value here. Okay, since x and y are both normally distributed, therefore the linear combination for all the x and y are also normally distributed. That means t is normally distributed, mean is 19950, and the variance is this one. Okay, then for the next step, they want you to calculate the probability that the total cost means t, Okay, it's between these two values. Oh, all right. So between these two values means that T is between 20,000 to 22,000. Since I know that T is normally distributed, right? So to find the probability, again, I need to standardize them. So minus the mean for the T divided by standard deviation. Okay, then this one Z. Also taking the value minus the mean divided by standard deviation. Okay, then from there, try to get the 3 decimal place for the value of the Z. Okay, and next I want to find out the probability for this particular area. So I will take Z smaller than 1.603 minus Z smaller than 0.039. So this idea, this concept is in actually chapter 5 under AS statistic 1. So please make sure that you know. If let's say you are not aware how to get this formula, maybe you can use some other technique that you learn all the while. Alright, so if you want to have a look, then you can go and have a look for statistics 1 video, chapter 5 that we use the normal distribution table to find the probability part. Okay, so I'm having Z smaller than 1.603. So go to the table, looking for 1.603. 1.60 is this one, and then you need to add the 3. This one, this 3 at the back. So add the 3 at the last digit of 9452. Okay, so from here you should get 9455, 0.9455. Then minus, for this one, 0.039. Go to the table again, looking for 0.039. 0.0 is here, 0.03 is this one, then add a 9. So please add 36 at the last 2 digits of this number. Okay, if you add 36 at the last 2 digits there, so by right you will get 5156. Okay, then simplify this particular answer here. By right you will get 0.4299. Okay, or personally I prefer to make it or simplify into 3 significant figure in the standard answer, so which is 0.430. Okay, yeah, so this is how we solve question number 4. Question number 5. A teacher models the number of girls and boys who arrive late for her class on any day by the independent random variable Poisson. G is Poisson distributed with the lambda 0.1. Boy B is Poisson distributed with the lambda 0.15 respectively. Find the probability that during a randomly chosen 2-day period, no girls arrive late. No girls arrive late. Okay, for this question, since we know that it is Poisson distribution, right? Okay, so to calculate the probability, you need to aware that the 0.1 given in the question is for 1 day. Any day means 1 day. And now we are interested for a 2-day period. Before we can calculate the probability, we have to change the lambda become 2-day one. So 0.1 is 1 day. You have to multiply it by 2 to get the 2-day lambda, right? So your 2-day lambda will be 0.2. And they are interested to calculate the probability that there's no girl arrive late. So girl arrive late equals to 0. So what is the formula for Poisson distribution? So just recall back a little bit, yeah, it should be E negative lambda, lambda power R divided by R factorial, right? Okay, so we'll be having E negative lambda, lambda power 0 divided by 0 factorial. Okay, so if you try to press calculator, by right, this is the answer that you should get. Okay, then of course we will correct it to 3 significant figure, which is 0.819. Alright, then let's proceed to part number B. Okay, so for part number B, find the probability that during a randomly chosen 5-day period, the total number of students who arrive late is less than 3. So instead of 2 days, now they are interested for 5 days. And they are looking for the total number now, not only girl or only boy, but both of them, both girl and boys. Alright, okay, so first of all, we need to know that what is the lambda for the total of girl and boys in 5-day period? Therefore, you have to adjust our lambda value first. So originally, girl is 0.10, boy is 0.15, right? So you should actually take 0.10 plus 0.15. This is a total, and the one to multiply with 5-day period. Okay, so in short, it is 0.25 times 5. So your new lambda for the total of girl and boy in 5 days is 1.25. So this is your lambda. And they are saying that the total number of students who late is less than 3. Okay, so it's less than 3. So again, I will need to include the probability for x equals to 0, x equals to 1, and also x equals to 2. Not including the 3, right? Okay, so I will take out e negative lambda first. The x equals to 0 term is always a 1. X equals to 1 is always a lambda. Okay, then x equals to 2 will be lambda square divided by 2 factorial. Okay, then again, by pressing calculator, you will get a long list of number. Okay, so we'll correct it to 3 significant figure where it should be 0.868. Alright, yeah, so this is what we have for the part B. Let's continue further for part C. Okay, so for part C, it is given that the values of G equals to R and also B equals to R for R greater equals to 3 are very small and can be ignored. What does it mean? Say? It means that if you have the calculation in your calculation, if you want to calculate G equals to 3, you can ignore because the value is very, very small until we can ignore it. Okay, and then if let's say they are giving you B equals to 3, we also can ignore the calculation here because the value is very, very small. So you just ignore them. So that's meaning lah. So if let's say G equals to 3, 4, 5, 6, and so on, we'll just ignore all the value. Same thing happened for the B, right? Okay, and now they are saying that find the probability that on a randomly chosen day, on a day, one day, more girls arrive late than boys. Okay, so for this question, actually it's a bit tricky. Alright, when they are saying that more girls arrive late than boy, most of the students, they might thinking of this one, girl, more girl than boy, so girl greater than boy, alright? So we might want to calculate probability in this way lah. G greater than B. But like what I told you just now in one of the question, I cannot find a probability when both sides also have a random variable. So I have to move all the random variable to one side. So G minus B greater than 0. Okay, but some students will think, okay, how can I find out the lambda for G minus B? So they will assume that it is Poisson distributed. But if you are using this technique where you assume that G minus B is Poisson distribution and you calculate the probability in Poisson, basically it is wrong. Okay, this is not the correct method. Although it looks like logic and also quite true, right? When you look at the steps, it is like quite normal, quite natural, right? But basically this is a wrong technique and wrong method. Okay, so what's the reason that I cannot use G minus B and let it become Poisson distributed? It is because of if you try to find out the mean for G minus B, right? So you're having EG, which is 0.10 minus EB, which is 0.15. So you get negative 0.05. If you try to find the variance for G and also the B, okay, so for your information, like what we learned just now, the variance of G, there's no minus, right? It should be a plus the variance of B. So it must be a plus. Sorry. Then what's the variance of G? In Poisson distribution, mean and variance are the same value, right? So I should have 0.1 plus 0.15. And from here, you get 0.25. Okay, and when you try to get the mean and also the variance for G minus B, right, you realize that the mean is negative 0.05 and the variance is 0.25. These two values are not the same. That means it is not Poisson. Because if let's say we want to make sure that a variable is under Poisson distribution, both the mean and variance must be having the same value. But if you double check for this random variable, you realize that the mean and also the variance for the variable G minus B are not the same value. Therefore, you can use the Poisson method to solve them. Okay, so if you cannot use the Poisson method to solve them, then how are you going to solve them? So we have to list out all the possible cases one by one. All right, so as an example, I will show it in detail here. So this explanation part, please take note, yeah, because I believe that there are some students, they might want to use the idea where straight away use the Poisson formula and solve it. But this question is not the correct one to use the Poisson. All right, so if now Poisson is not the method that we can use, then we want to get the probability more girls than boy. More girls arrive late than boy. There's no other option. You have to actually list out the cases one by one. So we can start from small value first. Let's say I have one girl arrive late. I will not start from zero girl arrive late because zero girl arrive late means that there's no boy arrive late as well, which is not belongs to this case. They want to have more girl later than boy ma. Right. So if let's say girl equals to 0, then the only possible case for boy is equals to 0, but it is not belongs to more girls arrive late than boy. So I will start from G equals to 1. If let's say you have one girl late, it can be 0 boy late. No? So this case fulfill what we want here. More girls arrive later than the boy. Okay. So I think this is also the only possible result only. Okay. So the boy cannot be equals to 1 because if boy equals to 1, that means the number are the same. It is not true to fulfill the more girls arrive later than the boy, right? Okay, how about for the part 2? So I can try to consider the case when there are two girls coming late. If two girls coming late, then I can have 0 boy coming late. So this is also belongs to more girls arrive later than boy. One more case is I still have two girls arrive late, and then I can have also one boy arrive late. This case also belongs to more girls arrive later than the boy, right? Then is there any other value? So maybe you can try to consider G equals to 3. Okay, but for G equals to 3, right, like what is mentioned in the question earlier, for any value G equals to 3, B equals to 3, G equals to 4, B equals to 4, and so on, the number are very small and we can ignore them. Therefore, we will stop until the G equals to 2. We are not going to consider the value for G equals to 3 anymore. Okay, so these are the 3 possible cases that fulfill our question where the more girls arrive later than the boy. And now you want to calculate the probability one by one, case by case. So we are having G equals to 1 and also B equals to 0. These two are Poisson distributed and they are independent variable. If I'm not mistaken, they actually did mention, yeah, independent random variable. So to calculate this probability, you can multiply the probability together. For G equals to 1, it is E negative lambda power 1 divided by 1 factorial. Multiply with E negative lambda, this is for boy 1, boy equals to 0. E negative lambda, then lambda power 0 divided by 0 factorial. Okay, so this is the first one. Okay, then how about we look at the second one? G equals to 2 and B equals to 0. So G equals to 2, E negative lambda power 2 divided by 2 factorial. B equals to 0 means E negative lambda power 0 divided by 0 factorial. So you multiply these two variables together. So this is basically the green color one. Okay, all right. Then how about the third case? So for the third case, basically you should know that G equals to 2 and B equals to 1. So how should I write out the formula for G equals to 2 and B equals to 1? Okay, so g equals to 2. E negative lambda, lambda power 2 divided by 2 factorial. Okay, then E negative lambda, lambda power 1 divided by 1 factorial. So this is the third case here. Okay, since the variable are independent, therefore you can directly multiply the probability together. Alright, okay, and from here, use the help of calculator lah, of course. So, and simplify the answer, correct to 3 significant figure. By right, you should have 0.0824. Alright, yeah. So this question is a little bit tricky, yeah. So please make sure that you take note on this. You shouldn't use Poisson, G minus B as Poisson random variable to solve it, okay? Right, then let us continue to the part D. Alright, so for part D, following a timetable change, right, the teacher claims that on average, more students arrive late than before the change. So highlight the keyword more students arrive late. So the keyword more tell us that this is something that we want to test later, whether is it true or not. During a random chosen 5-day period, a total of 4 students are late. So for 5-day period, 4 students are late. So this one is the observed value for us to calculate the p-value later. Observed value. Okay. Test the teacher's claim at the 5% significance level. Alright, so we actually want to run a test for this question. Okay, so first of all, I need to set up the null and alternative hypothesis. Right, then they are talking about the students who arrive late, right, without looking at either girls or boy. So originally, for 1 day, our lambda is 0.25 because 0.1 plus 0.15, you get 0.25 for 1 day. But now we are interested for 5 days. So for 5 days, you have to take 0.25 multiplied with 5. And therefore, you get 1.25. So that means originally, before the timetable change, we believe that the lambda should be 1.25 for 5 days. And after the timetable change, the teachers claim that is having more students arrive late. So we want to see whether this claim is correct, this statement is true or not. So we need to put it under the alternative. And it is again for more students. When we are having more students arrive late, means that the teacher actually feels that we are having more, the lambda is more than 1.25. Correct or not? Alright, so for 5 days. Alright, yeah. So this is what we have for the null and alternative hypothesis. Okay, then second step, we have to calculate the p-value. So to calculate the p-value, we have to use the observed value and calculate it. So we are having a total of 4 students. Okay, so for 4 students, this is a one-tail test. So when you want to calculate the probability, right, the probability for the rejection area, we should focus it on the right-hand side. This is one-tail test on the right. Therefore, our calculation for the area also should be on the right. And my sign for the 4 here should be greater equals to 4. Okay, so how can I calculate the probability for x greater equals to 4? So again, we are still under Poisson distribution. Therefore, we have to use Poisson formula to solve it. So x greater equals to 4, I can now find the probability. Correct or not? Because it should be start from 4, 5, 6, 7, 8 until infinity. So what I need to do is I need to take 1 minus the probability of x smaller than 4. Okay, E, negative lambda. When x equals to 0, it is 1. When x equals to 1, it is a lambda. When x equals to 2, it is lambda square divided by 2 factorial. X equals to 3 is lambda power 3 divided by 3 factorial. Okay, and by right, I will get the probability 0.0383. And for your information, this 0.383 is actually the p-value that we have. Okay, and this is the second step that we have, like we calculate the p-value, and after that I need to compare my p-value with the significance level, and from there I want to make a conclusion. Okay, so my significance level is alpha lah, right? So alpha is 0.05 and my p-value is 0.0383. So if I compare these two values, right, I realize that my p-value is smaller than the alpha. What's the meaning that the p-value is smaller than the alpha? Okay, so as an example, let's say I'm drawing a diagram here, but it is not the correct diagram. So just help us to visualize a little bit about the decision that we want to make lah. Okay, so for this test, we know that our rejection region is on the right, correct or not? So I highlight or shaded the rejection region. So my rejection region is on the right. This rejection region is having the area 0.05. Okay, so this is the rejection region, yeah? And if you have a look for my p-value, if I want to put in my p-value inside the diagram, right, it is having a smaller area. So when I draw, I have to draw a smaller area on the right-hand side as well. So the red color one is my rejection, is my p-value. So when you put in your p-value, when you draw the area, what is this line? The borderline of the area falls still under the rejection region, correct or not? It is still under the rejection region. Therefore, from here, I know that I need to reject the null hypothesis. Okay, so when you reject the null hypothesis, means what? Means that the teacher's statement is correct, because the null alternative hypothesis means lambda greater than 1.25. You reject the null. That means you do not reject the alternative, correct or not? Okay, so once you reject the null hypothesis and you make the decision already, okay, so I erase the graph here. This diagram shouldn't be shown right in the solution because it is not the correct graph. All right, so after you make a decision here, you need to make a conclusion statement. All right, so there's sufficient evidence to show that the teacher's claim is true. Alright, because we already reject the null hypothesis ma. That means for all the value that we collected here, right? Okay, can show or enough to show that the teacher's claim is actually a true one. Alright, so this is how we make a conclusion. Okay, yeah, so this is how we solve this question number 5. Okay, so we are now at question number 6. There's the graph of the probability density function of f of a random variable x is symmetrical. So highlight the word symmetrical about the line x equals to 2. It is given that the probability x between 2 until 5 is this value. So use only this information to show that p greater equals to -1 is this value. Alright, so since they are telling us a very important keyword, symmetrical about the line at x equals to 2. Okay, maybe I don't know how the graph look like, but I just simply draw any symmetrical graph. And then I know that this particular value here, 2, okay, is a center line, symmetrical, and line x equals to 2, right? Okay, then the probability from x until 5. Okay, this particular area inside is 117 over 256. Okay, so since it is symmetrical, therefore, from 2 to 5, it is 3 unit, right? So that means from 2 minus 3, that means from 2 until -1 should be having the same area, which is 117 over 256. Okay, because they are symmetrical at this line. Okay, so by right, at -1, this is the value that we have. And then again, because they are symmetrical also, so to get the probability by the side, these two values should be the same as well. So what you can do is like, maybe you can take 0.5 because half of the graph is from 2 until the end. So this whole area should be 0.5. Then you can take 0.5 minus 117 over 256. Okay, then if I want to get the probability for x smaller x greater than 1, so what should I do? Okay, so maybe this is what we can do for now. So first, I draw this diagram, okay, just to visualize clearer, like how are you going to use all this value and get the answer. I want to get the probability of x greater than -1. If you have a look from the diagram, x greater than -1, it means that I want to include the area for x between -1 until 5 and also x greater than 5. From -1 until 5, like what I showed you just now, it is actually 2 times of 117 over 256. Okay, then plus, for the area of z greater than 5, like what I told you also just now, you can take 0.5. The green color one is 0.5, half of the graph, minus the 117 over 256. Okay, and from here, so suppose you should get the answer that they want us to show, 245 over 256. Okay, so this is what I expect, right? But of course, the original graph might not something like that, might not be something like this. Okay, it just help us to visualize the question clearer. All right, then let's have a look for part 2, part B. It is now given that for x in a suitable domain, this one, where k is a constant. So just now they tell us we have a function f, but we don't know what is a function. And now they tell us that the function f is basically like this. And they want us to find the value of k. Okay, if I know my function f is this one, to find the value of k, I can use any result available in part A. Okay, so maybe you can try to use this result given in the question. X between 2 until 5 is equals to 117 over 256. So maybe I'm using this result here. Okay, so the probability of x between 2 until 5 is equals to 117 over 256. Okay, then to calculate the probability for continuous random variable, you have to integrate them, right? So you integrate the function fx. And you let it equals to 117 over 256. Alright, then after that, if I want to get the probability, right, I should integrate them. So before integration, I prefer to take out all the constant before I start integrating them. Alright, so integrate a 12, you'll get 12x. Integrate 4x, you'll have 2x squared. And integrate x power 2, you'll have x power 3 divided by 3. Then, of course, you want to substitute in the limit 2 and 5. Okay, right, then now try to substitute in all the values. Okay, substitute in 5 into the first time, I will be having 60. And the second time, I will be having 50. And after that, the third term is 125 over 3. And now I want to substitute in the limit 2 inside the terms here. So into the first term is 24. Into the second term is 8. Third term is negative 8 over 3. Alright, and simplify the number on the left, you will get 39k. It is equals to 117 over 256. And from here, your k is equals to 3 over 256. Okay, yeah, so this is how we get a value for k. And let's proceed to part 3, part C. Okay, so a part C, they give us another different random variable x with this probability in function g. Okay, so gx equals to 2 over 9 and then 2 plus x minus x squared. The domain of the x is all the values x for which gx greater equals to 0. So for this question, right, you need a little bit of maths knowledge. Yeah? They are telling us that the domain of x is all values of x for which the gx is greater equals to 0. Alright, so gx equals greater or equals to 0 means that the function g is positive. So when the function g is positive, the value of x there will be the domain of this probability density function. Okay, so first of all, we need to know how is the function gx look like. Alright, so I didn't draw in detail. Okay, maybe first of all, I try to factorize the function first. if I try to factorize this function, I'll be having x plus 1 and also 2 minus x. If I try to factorize it out, and because of I'm having negative x squared, the term negative in front of the x squared basically tell us that we are having the n-shaped graph, right? A n-shaped quadratic curve. Okay, and then for these two brackets, I will get x equals to -1 and also x equals to 2, which means that x equals to -1 and 2 are actually the roots for this particular function when the function is equal to 0. If you try to observe or try to sketch the diagram a little bit, by right, I didn't draw out the exact diagram, okay? So by right, it should be something like this. So I'm having the graph pass through -1 until 2, and then it must be an N shape. It might look something like this. Okay, so when gx is positive, greater than 0 means this part. So for this part, what is the domain? So from -1 until the 2. So the domain for this particular function in this random variable x is actually -1 until 2. So this is how we decide the domain of x. Okay, so we need this one before you can continue to get the variance here. Right. Okay, so once I know that my domain is here already, okay, so we can make a small calculation here. All right, so I can write it out as this one. Gx is equals to 2 over 9, and I'm having x plus 1, 2 minus x. Okay, and this tells us that we are having the graph like this. Okay, so I just copy this one and move it up. Okay, so my graph basically looks something like this. Okay, and from here, from the diagram, I know that my domain, my domain, can I just erase it a little bit? Okay, cannot erase, never mind. Right, so my domain, from here you know that gx greater than 0 when x is between -1 until 2. Okay, yeah, so from here I have known the domain, and now I can continue to get the variance. Okay, so before I can get the variance of x, I need the expected value of x first. So what's the expected value of x? You need to integrate the domain for the function, multiply the x together with the function gx. So you multiply it together with the function gx before your integration. Okay, then again, 2 over 9 is a constant. I prefer to take it out. So I'm having 2x plus x squared minus x power 3. Alright, then from here, only I start my integration. Integrate 2x, I will be having x squared. Integrate x squared, I'm having x cubed over 3. Integrate x cubed, I'm having x power 4 divided by 4. Then put in the value 2 and -1. Okay, so if I didn't do any careless mistake, right, substitute in the value 2 and 1 first. So first term is a 4, second term is 8 over 3, then the third term is 4. Substitute in -1, I'll be having 1, second term is -1 over 3, the third term is 1 over 4. Okay, so simplify everything here, I will get the half. Alright, so this is the expected value of x. Then to get the variance x, what we need is, we need also the value of expected value of x squared. So how to get the expected value of x squared? So again, the concept is the same. You multiply x squared together with the function g. This is your function g again, right? Okay, so a moment, yeah. Okay, this is your function g. 2 over 9. Then 2 plus x minus x squared dx. Okay, so I'm having 2x squared plus x cubed plus minus x power 4. This is before integration. So after the integration, what will I have here is, I'll be having 2x power 3 divided by 3, x power 4 divided by 4, then x power 5 divided by 5, then 2 and -1. Okay, so I will try to put in all the value, yeah? So substitute the 2 inside the first term, I'll get a 4. sorry, not the 4. I think it should be 16 over 3, not a 4. Sorry for that. So 16. 16 over 3. Substitute 2 into the second term, you'll be having 4 actually, 16 over 4. Then the third term is 32 over 5. Then substitute negative 1. First term is negative 2 over 3. Then second term is 1 over 4. Third term is 1 over 5. Okay, so you do all this substitution, just make sure that you don't do careless mistake because there are negative sign here and there. Alright, so very easily we might make some careless mistake. So just make sure that you try to avoid it. Okay, and the expected value for ex squared is 7 over 10. Okay, alright, so once I get the value for expected value for x and also expected value for x squared, then from here I can get the value for the variance. So what's the variance formula? Okay, so variance x can be found by using expected value of x squared minus the square of expected value of x. So which means you are taking 7 over 10 minus 1 over 2 and you square it. Okay, then from here by right, you should get 9 over 20 as the variance of x. Alright, yeah, so this is how we solve question numbers. Alright, so the last question for this paper, question number 7. The height in centimeter for adult females in this place, Lithuania, have mean mu and standard deviation sigma. It is known that in year 2004, the values of mu and sigma were these two values. Government claims that the value of mu this year greater than it was in 2004. So the keyword is greater than. The keyword greater than will help us to form the alternative hypothesis if you want to run the test later. In order to test this claim, the researcher plans to carry out a hypothesis test at 1% significance level. He records the height of a random sample of 300 adult females in Lithuania this year and also find the value for the sample mean. Okay, so first of all, they want us to state the probability of a type 1 error. Okay, so for type 1 error, right, before we can decide it, let's have a look what kind of distribution do we have for this particular test. We are having the population mean. We are testing the population mean for this year, right? Okay, so we are testing the population mean. Therefore, we need to know that he are taking a random sample. So this random sample is having 300 adult females. Okay, so for these 300 adult females, this is the sample mean, n equals to 30. When your sample mean is large, right, where n greater equals to 30, then the distribution for the sample mean is approximately normal distributed because of we apply central limit theorem when the sample size is large. So no matter the original population is normal or not normal, so when my sample size is large, then basically the sampling distribution is approximately normal distributed. So when you're having the normal distribution in the hypothesis test, basically the type 1 error will be the significance level. So I'm having the type 1 error is the significance level under a continuity correction. If let's say you're having binomial or Poisson, which is discrete one, then you're having the type 1 error where you need to recalculate it. But for normal distribution, which is a continuous random variable, the type 1 error directly is the significance level that we have. Okay, then now you should assume that the value of the sigma after year 2004 remains the same at 6.95. So they want us to, given that the mu for this year is this one, find the probability of a type 2 error. Okay, so if I want to find out the probability of type 2 error, I need the acceptance region first. Okay, so just to recall back a little bit, yeah. So what is the definition for type 2 error? So type 2 error definition means that we want to accept the null hypothesis when the null hypothesis is false. We accept something that is not true. Okay, so accept null hypothesis means you need acceptance region. How can we find out the acceptance region? Okay, so first of all, we want to find out the rejection region first. And again, how can I find the rejection region? It is related to the test that we have here. Okay, so like just now, I already know that in my hypothesis test, I'm having a normal distribution because I'm using the sample mean, right? The sample value. And I did tell you just now as well, for alternative hypothesis, right? It should be mu greater than a number that we have. So when you have mu greater than a number that you have, the keyword is greater than, therefore the alternative should be greater than. Your rejection region will be on the right hand side. So this will be my rejection region. And this area is significance level, which is 0.01. So the small area here is 0.99. Okay, then what is this particular value of the Z that separate the critical value, that separate the rejection region and acceptance region? So this critical value, we need to look at 0.99. So 0.99 is 2.326, right? So that means this value of Z is 2.326. Okay, and what are we going to do now is, I know that this is a rejection region. That means what? That means my rejection region is at the part where Z greater than 2.326. Okay, so like what I show you here, I know that this particular value is a Z. So any area that's more than Z, it is fall under the rejection region. Therefore, my rejection region is Z greater than 2.326. Okay, so what is the formula for the Z? Since we are using a sample mean to run the test, right? So you have to use sampling distribution, where I'm having sample mean minus the population mean divided by standard deviation over square root n. And it is more than 2.326. Okay, so if we try to observe the value here, right? I already know all the sample mean. I know the mu. The mu is 163.21 because we are using it to compare with the year 2004 one. So it is 163.21 for our mu divided by sigma. What is my sigma here? 6.95 over square root 300. Then I'm having 2.326 here, still the same. Rephrase all the number and bring it to the other side. By right, I'll be having min x equals to this one, greater than this one, 164.1433271. This will be my rejection region. And of course, if I want to get the acceptance region, then basically it's the opposite sign for this. Okay, all right. So now, once I get the rejection region, I can start finding out the type 2 error. So what's the definition for type 2 error? I accept the null hypothesis when the null hypothesis is false. Okay, so when I have accept null hypothesis means I need to put in the acceptance region. So this is my acceptance region. Given that the null hypothesis is false, that means my mu is not 163.21 anymore. So if let's say my mu is not 163.21, right? They need to give us a new value for the mu. And the new value of the mu is given here, which is 164.91. Okay, so I put in mu equals to 164.91. How can I calculate the probability for the sample mean here? Again, they are still normally distributed. Okay, so I have to change it become Z, where I take this original value. I usually will use the original one and the long value here, minus the new mean, divided by the standard deviation, 6.95 over square root n, so square root 300. Okay, so find out the value for the Z up to 3 decimal places. This area should be the same, like Z greater than positive 1.911, right? So I have to take 1 minus the probability of Z smaller than 1.911. So look at the table, 1.911. So you add the value inside, you have 0.972. Okay, so you have 0.972. Okay, then simplify everything, you get 0.0280. Yeah, so this is how we actually find out the type 2 error. Okay, so that's all for this paper, and thank you very much for watching the video.